Alright, so today what we're going to end up doing is solving some inequalities. So let's take a look at a problem here. We'll take a look at number 1. And let's say we had a two-step inequality. 2m plus 1 is greater than. So when I read it from left to right, if it's open towards what I'm reading on the left side, then I would say greater than. So 2m plus 1 is greater than 13. So I solve this just like an equation. So what I'm going to do is just opposite operations to isolate this variable m. So I'm going to take away this 1 from the left-hand side. So I isolate that variable. And when I do that, in order to keep this in balance, I also need to take 1 away from the right side. So when I do that, I still have this 2m, and it's still greater than, and then I subtract the 1 from 13, and I get 12. So I have one more step to do in order to get m by itself, and that's to divide by 2, because the 2 is right next to the m. When a number is right next to a variable or parenthesis or absolute value, that means multiply. So to undo that multiplication, we're going to divide. So once I've divided by 2, I've got the value of m, but m, even though 12 divided by 2 is 6, m is not 6. It's an inequality. M is greater than 6. And so to show this, sometimes we draw a graph to represent this. When I draw the graph, I like to put the number that is like an end point for this inequality in the center. So I'll put 6 here. And then I like to put the number that's bigger than 6, which is 7 on the right, and the number that's smaller than 6 on the left. And since m is not equal to 6, but it is every number that's bigger than 6, I'm going to use a symbol. And the symbol I use is an open circle. And I put an open circle right on the 6 to show that m is not 6. So it's not 6, but it is every number bigger than 6. So to show that, I draw an arrow in the direction that shows the possible values for m. So m is not 6, so I use the open circle, but m is every number bigger than 6. So I draw the arrow towards the bigger numbers. So let's take a look at another example. Try number 2 here. And let's say we had a 2c, and then a minus 4 is less than or equal to, we'll go with a negative 8. And so the first step, again, is to isolate the variable c. So we want to remove this minus 4. So the way we're going to do that is to do the opposite of a minus 4, which is plus 4. So we'll add 4 to both sides. And when I do that, I end up just having that 2c. 2c is now less than or equal to, and then I have to subtract these two numbers because they're opposite in sign. So there's more negatives than positives, so that's why it's a negative 4. And again, I read this inequality as less than or equal to because I'm reading from the left side here, the 2c first, and it points towards the 2c. So 2c is less than or equal to, the line says or equal to, negative 4. So my next step is to eliminate that coefficient, the coefficient of 2. The coefficient is the number always in front of the variable. So I'm going to divide by 2 on both sides. And what I'm left with is c is less than or equal to negative 2. So now I've solved it, and this is the algebraic form of the solution, but it's also nice to have a graphical form. And so the way I like to do that, again, is to draw a line to represent the number line, and the end point, negative 2, I like to put in the center. And then I put the bigger number to the left, or to the right. The bigger number is negative 1, and the smaller number is negative 3. This time, we have a different inequality. Not only is it less than, it's less than or equal to. So to show that the value is equal to, I'm going to use a different type of circle on the negative 2. I'm going to fill in the circle on the negative 2. So the circle represents the end point. That's where the values of C end, and they're either to the left or to the right of that number. And so it's a filled-in circle opposed to an open circle because it equals negative 2 along with being every number less. So to show less, I need to go toward the smaller numbers. And to the left are the less values. And so we have the values of C are less than or equal to negative 2. In the next example, we're going to end up seeing where we divide by a negative or multiply by a negative, and we'll have a different situation, something different that will occur. So we'll see that in part 2.